Okay everyone, this is the last video of the night, and now that we know what the different kinds of equations are, we're going to go over how to predict products. So over here on the side, I have the reactants in an equation. I have calcium hydroxide plus aluminum chloride, and what I want you to do is to predict what the products will be when I mix these two compounds together. So in order to do this, the first thing I need to do is determine what kind of reaction this is. So I'm going to assign a letter to every element and every polyatomic ion so that I can figure this out. So I've got calcium as A, hydroxide, OH, all together is B, aluminum is C, and chloride is D. So my general form for this equation is AB plus CD. Well, now I'm going to look over here at my reactions, and I see that it is a double replacement that has reactants of this kind. And what's going to happen in a double replacement is that the A and the C are going to switch places. So what I got is AD plus CB. And notice that I wrote the C first, and that's because the cation, the metal, always is written first in a compound. So now that I wrote the general form, what I'm going to do is write the element right below it that I've assigned to each letter over here. So I assign calcium the letter A, so below A on the product side I'm going to write Ca for calcium. I'm also going to take a look at the periodic table. I know that calcium is in column 2, and therefore it has a charge of +2. Letter D is chloride. Now, chloride is simply Cl. Notice that I did not carry over this subscript of 3. And the reason why is because chloride is not a polyatomic ion. You only carry over the subscripts for polyatomic ions like nitrate, which is NO3, or sulfate, which is SO4. Chloride is none of those, so I do not carry over the 3. What I do need to do, though, is determine the charge of chloride. And since chlorine is in group number 17, I know that chlorine has 7 valence electrons. Well, I can get the charge of chlorine by subtracting 7 minus the number 8, and that gives me a charge of -1. So chlorine has a charge of -1. So we're going to come back to that in just a second. Letter C is aluminum. Aluminum is in column 13, so I know that aluminum has a charge of +3. And then B is hydroxide. Hydroxide is composed of 2 capital letters, 2 separate elements, oxygen and hydrogen. You're not going to find hydroxide on the periodic table itself. Flip your chem helper over. That's where you'll find hydroxide in the list of polyatomic ions. Hydroxide has a charge of -1. All right, guys, we're not done yet. What we need to do is balance the charges. So all I do is the crisscross method, and for the first compound I get is CaCl2 plus, and now I'm going to do the same over here. Notice that the 3 is going on the outside of the parentheses for the hydroxide, and I get Al parentheses OH3. So I'm just going to rewrite my reactants here. All right, now to finalize this, I need to balance my equation. So I've got 1 calcium on the reactant side, 1 on the product side. I have 2 hydroxides on the reactant side, though, and 3 on the product side. So what that means is that I need to figure out a way to get 6 hydroxides on each side. Why? Because 2 times 3 is equal to 6. So I'm going to put a 3 by the calcium, and I'm going to put a 2 by the aluminum. So now my hydroxides are balanced. But take a look at calcium now. This side, the reactant side, has 3 calciums, and there's only 1 on the product side, so I'm going to alleviate that by putting a 3 there by that calcium. But now I've got 6 chlorides. To get 6 over on this side, I'm going to put a 2 there. And when I do that, that balances out my aluminums. So now I'm happy and balanced. And this would be your final answer. So that was a double replacement reaction. One other thing that you may be asked to do for a double replacement reaction is you may be asked to determine whether one of the 2 products is a precipitate. So take your packet and turn to page 25, or you should take your chem helper and flip it over to the back side so that you can take a look at the solubility table. I see that when I combine calcium and chloride together, I get an S. So I know right away that this is not the precipitate. And when I look at aluminum and hydroxide, I see that I have an I. That means that if the directions wanted me to, I would circle aluminum hydroxide as being the precipitate in this reaction. Remember that precipitates only occur in double replacement reactions. Right, let's do another one. I'm going to erase all of this. And let's do another example. Let's try magnesium plus, let's do silver chloride. So to start this off, I'm going to assign a letter to every element. Magnesium is A, silver is B, and chloride is C. I see that this would be a single replacement reaction. But before I do anything else, I need to look over here at my activity series. Remember that the activity series is found on the back of your chem helper. In order for this activity series, in order for this equation to work, I need to use the activity series to see if magnesium is strong enough to remove silver from this compound and kick it out. So I look at my activity series and I see that magnesium, that's not going to work. I see that magnesium is here and that silver is way down here at the bottom. Since magnesium is higher than silver, that means that magnesium can kick the silver out of this compound. So this reaction is going to continue to completion. So what happens next, if we look at our general form, is that I get B plus AC. Well, letter B was silver, letter A was magnesium, and magnesium being in the second column has a charge of +2, and C, chloride, has a charge of -1. When I write out this compound then for magnesium and chloride, do the crisscross method, and I get MgCl2. That's great, but I'm not done yet because I'm not balanced. So I've got 2 chlorides on the product side, only 1 on the reactant, so I'm going to put a 2 here, a big coefficient of 2, and that changes my silvers. So now silver has 2 on the reactant side, but only has 1 on the product side. So to change that, I'm going to put a 2 here. I have 1 magnesium on each side. Chlorines and silvers are balanced. That's my final answer for this problem. Let's try another one. Let's see. Let's try zinc oxide. And we want to see what this one's going to be. Start again by assigning a letter to every element. I'm starting out with AB. Well, the only type of reaction that starts out with AB would be the decomposition reaction. So that means that zinc oxide is going to fall apart. And the only way that zinc oxide can fall apart is into zinc and oxygen. That's going to be A plus B. So I'm going to write zinc plus oxygen. The thing that you have to recognize here, though, is that oxygen is a part of high Broncliffe, which means that this is a diatomic element. So the formula for oxygen is not just O, it's O2. And when that happens, we have to balance again. Put a 2 here in front of the zinc so that we have 2 oxygens on each side, and then put another 2 in front of the zinc on the product side. This way we have the same number of zinc and oxygen atoms on each side, and we're nice and balanced. All right, this will be the last one. Let's try aluminum plus lithium carbonate. Let's first decide what kind of equation we have here. We're going to assign aluminum the letter A. We're going to give lithium the letter B. And, oh, did I say chloride? I meant carbonate. CO3 is not chloride. It's definitely carbonate. I apologize for that. And my carbonate altogether will be the letter C. So my general form is A plus BC. Let's see what kind we have. That's right here, number 3. This is a single replacement. But look, we've got our little star here. That means that we have to look up at the activity series. In order for this to go to completion, my aluminum must be higher on the list than my lithium. So let's see if that's correct. Here's aluminum here, and lithium, is up here at the top. So lithium is high and aluminum is low. Well, aluminum is lower on the list. It cannot remove lithium from this compound. So, regardless of what the rest of the general form is, my answer to this is no reaction. Because aluminum can't remove lithium, therefore you're not going to have a rearrangement of atoms, and you won't have any new compounds on the product side. You can't even balance it. So that's it for the review. I'm going to send these along via email. I hope you have a good night, and I hope that this all helped.